Next slide, please. A little bit about IDEX Solutions. IDEX Solutions has been around since 1996, and we're a full service provider around the Dassault family of products. We handle CATIA, Innovia, 3D VIA, DELMIA for sales and support, as well as Intercim. What happened there? We do implementation services, automation, and training. We also have an engineering services department that does on-site staffing and process consulting. Next slide, please. So without further ado, I'd like to introduce John Todd, who's going to be making the presentation today. John is currently the VP for DELMIA Strategic Accounts at Dassault Systems. He has over 30 years experience in applying PLM, CAE, and manufacturing software systems to enhance productivity in aerospace, in automotive, and in life sciences. He's held executive positions at Control Data and SDRC. John joined Intercim as President and CEO in 1998 until the acquisition of Intercim by Dassault Systems in 2011. He holds 2 degrees, one in sociology/psychology and one in computer science. Without further ado, I'd like to introduce John Todd.
Thank you very much. Let me know when you see my desktop.
We have your desktop and your calendar.
How about if we try this?
There you go.
Okay. So again, I'm John Todd. I want to thank IDEX for inviting Dassault Systems to participate in a webinar yet again. We have a long relationship and it's a very effective one, so thank you. I should take about 45 minutes or so. Encourage any questions that you may have at the end. I'll try to save time for the end. This is a little bit of a commercial, but this was the announcement of the DS acquisition of Intercim in March of 2011. I won't belabor you with the details other than it's an exciting acquisition, and we'll get into why they did that in a moment. You just heard about the DS suite of applications and brands, DELMIA, Simulia, SolidWorks, Innovia, CATIA, and again, IDEX, 3D VIA. IDEX does a great job of representing DS, certainly domestically and in Canada as well. You can see that the company's grown. This chart's a little dated. We're over 10,000 employees now, and with a strong concentration in Europe and the Americas. So why did DS acquire Intercim? We started working with DS back in 2000 in a partnership arrangement, and those of you on the phone probably know that product life cycle management, in some ways you could argue, has been incomplete over the years and didn't include the manufacturing shop floor, much less maintenance, repair, and overhaul. So the intent in the strategy by DS is to close that digital gap, if you will, between concept, design, plant process planning, and so on, into the actual execution of building products and eventually into MRO. Where do we best fit? This is an analysis that our marketing team has done over the years. You can see that we're focused on what we call discrete, medium to low manufacturing cycle with very complex, highly engineered products. And they encompass traditional PLM, integration to ERP, PLCs, and so on. So that's where we're focused today. Clearly down at the bottom you can see another area that's growing rapidly, and we are entering that market as well as others in life sciences and so on for MES. Traditionally our success has been in aerospace and automotive and the associated supplier community. So I won't belabor with a lot of detail here, but this gives you a little view of what is called now DELMIA operations, formerly called trademark velocity from Intercim. It has process preparation and work instruction authoring capability, obviously execution, workflow system to address quality issues like nonconformance and so on, and the corresponding corrective actions. And then we have what we call operations intelligence, which labeled here as process understanding. And associated with all of these categories is the requisite reporting and visuals, if you will. Okay. A little more, the DELMIA operations, formerly Velocity product, is a web-based application based on Microsoft, and has a very open architecture for integration to the required order release processes and so on. Okay. So what is this? Why do you want to do this? Well, historically, execution in many environments, including OEMs, not just the supply chain, but on OEMs, was a paper-based model with some stovepipe applications to maybe address a quality issue here and there and so on. What this does is provide an integrated capability from planning, work instruction development, all the way through in-seat programming and most importantly, procedural enforcement, especially in highly regulated industries. This probably isn't surprising to you from a DS perspective. The focus is to try to, I'll say, make 3D on the shop floor more pervasive than it is. Historically, it's been what we euphemistically call 0D, 2D instructions for the operators and technicians on the floor. We see some real benefit in showing the actual 3D models with the origins coming from design engineering. Nonconformance and I'll say emergent process interruptions in the manufacturing flow is very common. We have a strong capability that's integrated tightly with the MES system to do that. And then traceability for as-built records down to the smallest component that your business requires, and your OEMs, where you have contracts, what are the contractual commitments to deliver back to the OEM. Ideally, that works better in electronic fashion than it does historical paper-based manner. Okay, so let's get into a little more detail on what process execution is, enforcing the planned process. Again, this shows a 3D view, but it doesn't have to be. Most of our implementations are using traditional two-dimensional text-based work instructions and migrating towards 3D. So the term BIOS is, if you're not familiar with it, most of you probably are, especially if you're in the aerospace industry, but that's just electronic signature capability. Okay. So what are some of the traditional things you have to do? Part data collection. And is it required by your contract or your internal organizational procedures to collect data on the proper implementation, assembly, or fabrication of a particular part, and so on. There's enforcement rules that says if a series, one or more of a series operations must be completed before proceeding on to another, the system will manage that kind of thing. Okay. Same thing for general data collection. You may have specific capabilities that you need to record, and particular values, are we in spec limits and so on, and the system has that capability as also. Electronic signature BIOS, that can be as simple as somebody recording that they completed a particular task. However, there may be some verification requirements which may require witness signatures or a quality sign-off and so on. Very common, and the system also does that kind of thing. Okay. Okay. Work in process status, labor data collection, calibration of tools, ITAR compliance. There's a long list of things here that is very common with any MES system, but in this environment, in an extended enterprise kind of scenario with a web-based capability, surprise, surprise, we think we do it best. Okay. Here's an example of a dispatch matrix with some semaphores over here showing the status. This is very difficult to read, but particular assignments by task and so on, and where they are with respect to precedence, whether or not there's a non-conformance involved, whether all of the parts, in this particular example, they're all green. If there's a part shortage, it would show up as yellow or red, that kind of thing. Okay. Emergent process management, what that is a name that DS has for many, many process workflows that are unplanned, if you will. The most common one of those is nonconformance. Okay? So 3D nonconformance makes it even better if you can visualize the actual part that it corresponds to the design intent coming from engineering, and we find some non-conforming part or process. We can record that in 3D and get it back to design engineering in an efficient, effective, quick manner. Let's say that you don't have to go all the way back to design engineering for engineering change order or so on, and it's something relatively simple that can maybe use an alternate part or a different fixture on an assembly, whatever it might be. There's a capability embedded in the program to insert operations and steps into the program to account for nonconformance or a simple deviation in the process flow. Again, another visual on a matrix of status of shop orders or operations. You can display these for shop floor workers, for shop floor management, or executives who are interested in a particular status of an upcoming deliverable or set of deliverables. The capability for doing that kind of thing is embedded in the product. Here's an exhaustive example from a couple of customers. This happens to be an OEM, but using the emergent process management capability that I described nonconformance for. These are examples of process flows that are developed and are being used across multiple disciplines: supply chain, operations, engineering, and obviously the shop floor and certification requirements. This is just to show that the capability is pretty exhaustive. So what do you need for traceability and genealogy? Many of you have probably experienced trying to reconstruct history. This system will record every single process and required step in producing, fabricating a product or assembling a final product, so that auditing should something be awry in the future, or you're in an MRO environment, you have an exact as-built genealogy of the capability you've just completed. Okay, I'm going to spend a lot of time on operations intelligence, but it is a unique capability that DS has. But in 2007, Intercim acquired a company in Paris who had 4 patented algorithms for pattern matching applied to manufacturing, yield improvement, reduced scrap, and so on. This is that'd be an exhausting presentation in and of itself, and we'd be happy to do that in a separate environment. But this will give you an example. If this is an example of a composite manufacturing process, and you can see that the variables associated with producing a good product are things like resin content, layout, room temperature, humidity in the environment, cool down time, how old is the raw material, and it's possible, and it occurs somewhat regularly, unfortunately, that every single one of these line items, fabric outlines, all of these things can be in specification in alignment with the original design, and yet you produce a part that's got some deformities, delamination, whatever it is. Even if everything individually is in spec, you can produce a poor part. What this capability does, and it's been applied at several OEMs like Boeing in Australia, Airbus in France and Spain and Germany, and many other of the composite suppliers. What this does is it identifies the best manufacturing path to consistently produce quality parts. And more importantly, it identifies when you have a combination of these variables, or many times it's a lot more than this, it might be 30 or 50 variables. And it will identify the combinations, even though things may look in spec individually, it'll find specific combinations that produce poor parts, and can identify and can alert the end user community and production management of a pending fabrication issue, and will allow for corrective action during the process itself. Very powerful capability, and we'd love to share that with you in more detail if you have some interest. That's kind of it for the product overview. I realize that was very brief, but what we're really interested in is if some of those capabilities are things you want to look at, we can get into more detail with IDEX support and coordination and so on. But lastly, I want to talk about, rather than product, I want to talk about an operations model for MES. I obviously don't know what the audience experience is with MES over the years, but like many software applications, there can be war stories. So, and it can be a complex implementation, which is mission critical. Once the system's operational, it really can't go down because it impacts bottom line on an hour-to-hour, day-by-day basis when it does. So how do you do two things? One, develop rapid deployment, so you're not talking about a 12 to 18 or even 24-month implementation, but something that's 6 months or less. And two, after you've successfully done that, how can you make sure the operations are sustaining? And so it's just a little advice from DS on our experience and what works best. So what happens, what are the constants in process MES execution? Every single one of these implementations, in a generic sense, does something called process plan creation, which includes the work instructions for the technicians on the floor and so on. There needs to be a process plan approval process in place. If a plan is complete, who needs to approve it? You know, is it the DME management? Does design engineering have to approve it? Those things are very common. And then an order release process. How do you get the prioritized set and precedence for orders, operations, and steps into the execution system? That requires an order release process, typically from an ERP system. You'd be very pleased if every single production run created the happy path and produced a quality product at the end. We know that's not true. However, you need to make sure that the system is configured to head that direction. So you need to create the process flow and configure the system to allow for the happy path. When that doesn't, when an unfortunate occurrence happens, you also need a nonconformance and a disposition planning capability. All of those things can be stood up in a short period of time and get the user communities familiar with those capabilities. And our recommendation is that although this is out of the box, it's incomplete without integration to legacy systems like ERP for order release, PLM systems to make sure you've got the latest design, and so on. So what does that mean? Well, this is without the name being displayed, this is an example of a short 6-week, 8-week long deployment standing on out-of-the-box pre-production proof of concept. And as you can see, it has all 5 of those issues: plan creation, approval process, order release simulation, happy path, and nonconformance. And in this case, they also had an external system for integration to configuration management system. So what we did is we created the basic permissions and user setup and configuration prep in the first week. In the second week, we configured all of these, in this case, 6 functional capabilities without accounting for anything inside of the specific processes for this particular client. Then what we did is we turned this initial configuration over to a subset of an end user community and ran the actual execution of DELMIA operations in parallel with their existing process. The intent would be to find out, all right, what needs to be done to make this production worthy? So here's the sequence of events for deploying and then sustaining, and some recommendations on sustaining. You do this pre-production out-of-the-box config as outlined on the chart before. And the intent here is minimize internal resource disruption. Putting a system like this in, you don't want to slow down your expected rate of production. But the interesting thing is, if you do this, you have a greater than 80% probability of having a functional system in 8 weeks. And by 80%, I mean the functionality needed to have an electronic system. What do you need to do after that? You need a close collaboration with the client and DS consulting to understand the requirements to fill out integration gaps and so on. Most common are the integration to ERP for order release and so on. It could be to an existing quality system as well. But there's a lot of things like that that is another week or 2 to do that, and then you can come up with a level of effort to actually get to production once you do this integration and so on. Now you follow that with, at some point, probably early in the cycle, training the subject matter experts, followed by end user deployment. We recommend that in the initial deployment you have some SMEs actually on the floor, because there'll be a lot of questions. People may not have caught everything in the training and so on. little typo here on this next slide. It should read MES is a mission critical application, not ID. But once you're in production and you're ready to have a sustainability model, realistically you're going to need one or more full-time equivalent IT/operations experts who make sure that this system is performing as planned, helping out the end user community and so on. And if you think about it, an MES system is not dissimilar to an ERP system. And you look at, or an MRP system, if you look at what IT organizations in manufacturing firms have for staffing and support, ongoing support of ERP, it's likely to be multiple people, or in the case of an OEM, hundreds or even more. MES is not that labor intensive, but you got to be realistic and know that you've got to have at least one FTE to make sure this the system stays up. If it's not up 99.99% of the time, you risk losing money. Okay, last slide, and I finished in 30 minutes, not 45. But these are the key points, key takeaways. It's a web-based application, so that if you have disparate locations, you can have a single instance of the product. It also makes maintaining the product from an IT perspective much simpler than having to deploy software installs on, around PCs around the company. This is a little redundant. It obviously provides real-time visibility of shop floor operations. Where are we with particular orders or operations and so on. Procedural enforcement in data collection, BIOS, certifications. If somebody qualified to perform a particular task, this system does that. A complete electronic as-built record is there. I mentioned WIP before. That's a very common look at that management on the shop floor looks at. Where are we with work in process? What's behind? What's ahead? Can we move people around to catch up, and so on. And the most valuable piece of this is making sure that product quality and deliverables, on-time deliveries, and yield is very high, and reduce scrap. We have another example of another company that no longer has to do manufacturing audits. When they ship product, they ship an electronic record of the as-built capability with it, and it's essentially eliminated any on-site audits from their contracted OEM or so on. Okay, so that's my presentation. We have plenty of time for questions. I'll stay on the line and turn it back to Susan.
Thanks, John. Are there any questions out from the floor? Everybody got all of that? There's going to be a test. Well, if there are no questions, I want to thank everybody for attending today and hope to see you again the next time we have our webinar. Thanks so much. Goodbye.
Thank you. Bye.